In this class, I am going to explain the practical inverting amplifier. So, in this third unit, we have a topic inverting or non-inverting amplifiers. In the inverting or non-inverting amplifiers, in yesterday's class, I already explained about the ideal inverting amplifier and ideal non-inverting amplifier. Inverting amplifier, ideal inverting amplifier and ideal non-inverting amplifier. In today's class, I am going to explain the practical. Yesterday's only ideal inverting and ideal non-inverting I already explained. In today's class, in the inverting amplifier, I am going to explain the practical inverting amplifier. What happens to the output when we are using this practical inverting amplifier? I am going to explain in our class. Okay, here we have a practical inverting amplifier. I have a circuit for this derivation part. I have taken the op amp with the simple resistors and the input voltages to the op amp. I am taking this is an inverting and this is non-inverting. For the inverting terminal, I apply VI. This is a practical inverting amplifier now. So, I am applying the input to the inverting amplifier. R1 is a resistor across the inverting amplifier, and the non-inverting terminal is kept to ground. And here, V0 is output. I can add the feedback resistor RF to the op-amp circuit through this inverting and to the output. So here A is the node across the inverting terminal and the B is the node. The voltage across this node A is VA and the voltage across the node B is VB, and the current across the R1, current across the inverting terminal is taken as an I, and the current across the feedback resistor is taken as an I1, and current across from the node A to the inverting terminal is taken as an IB1, and current across non-inverting terminal is taken as an IB2. So here I have this circuit for the designing of a practical inverting amplifier. It is very simple. So in this practical inverting amplifier, it is not applicable any differential, that means it is not applicable any voltage, that means here we are in yesterday's class we are going to take the virtual ground concept. For these virtual ground concept is applicable to only ideal inverting amplifier. In yesterday's class, I already taken the virtual ground concept in the ideal inverting amplifier. But in this practical inverting amplifier, we not apply virtual ground concept. Ground concept. Why? Because ideal means it is not unreal. It is our imaginary. But in the practical inverting amplifier, it is real. So here, virtual ground concept is not applicable. So here, in the virtual ground concept, we already know about that VA is equals to VB. So here, VB is equals to VA. So, but in this practical inverting amplifier, VA is not is equals to VB. VA is not is equals to VB. So here, the inverting amplifier is connected to ground. So voltage across the node B is 0 because we apply the power supply. We not apply power supply here, but here we can apply power supply. So VB is equals to 0, and so here we have an apply KVL law, apply KCL law at a node A. Apply KCL law at node A. At node A, apply KCL law. So here, entering current is equals to leaving current. Entering current is I, and the leaving current is IB1, and the I1 is the leaving current. So I is equals to I1 plus IB1. we have condition IB1 is current flowing through this inverting terminal. Due to this inverting terminal, we apply the VA as a supply to this inverting terminal. Here, R1 is a high input resistance. So we have used in the inverting terminal R1, which is having high input resistance, which is having high input resistance, high input impedance. High input impedance. So here current flowing through this is 0. Why? Because we are taking the R1, which is having high input impedance. So current flowing through this inverting terminal is taken as 0. So we can get IB1 is 0. Why? Because R1 which is taken here, which is having high input impedance. So this becomes, the equation becomes, so IB1 value 0 means we can get an I is equals to I1. So this is taken as a first equation. We can get an I is equals to I1. Why? Because IB1 inverting terminal, current flowing through this inverting terminal is IB1. The current flowing through this inverting terminal is 0. Why? Because we are taking the R1, which is having high input impedance. So current flowing through this impedance means current against it against with the current. So IB1 is value 0. So substitute 0 here. I can get I is equals to I1. So here I can substitute here again for the easy explanation. So here inverting terminal, non-inverting terminal, ground V and the node V0, RF, A, VA and the VB, IB1 and IB2, R1 and VA, simply like this. So here I is the current flowing through the inverting terminal and I1 is the current flowing through this and that's it. So here from the voltage divider rule, I can get an I is equals to VA minus VA by R. From the voltage divider rule, I can get VI is equals to VA minus VA by R1. And I1, apply voltage divider rule at I1. I1 is equals to VA minus V0 by R. So I1 is equals to VA minus V0 by R. So we have already I is equals to I1. We have already from the first equation we have I is equals to I1. Obviously we can write here VA minus V0 by RF is equals to VA minus VA by R. I is equals to I1 now. So we can equate those two. I is equals to I1. VA minus V0 by RF is equals to VA minus VA by R. Then from the op amp we have formula from op amp we have in the place of an V0 V0 is equals to AOL into VD. We have from the op amp circuit we have our formula V0 is equals to AOL VD. So here I can forgot one thing. So here in this practical operational amplifier, the differential voltage between these two terminals is given as VD is equals to VB minus VA. So here voltage difference between these two VD is given as between inverting and non-inverting terminal. The voltage difference between inverting and non-inverting terminal, VD is equals to VB minus VA. So you can already have VD is equals to VB is taken as 0. Why? Because it is connected to ground. VB is taken as 0 and VA is taken like VA. So we can get an VD is equals to VA means we can have only VA VB means voltage across this non-inverting terminal is 0. Why? Because we are connected to ground. Here the voltage across the non-inverting terminal is VA. So we can write like this VA. So here we can get an VD is equals to minus VA. VD is equals to minus VA. So in the place of an V0 is equals to AOL VD, we can write V0 is equals to, from the op-amp we can take like this for the simplification purpose. AOL into VD means we can get a minus VA. Minus VA. So we have an VA terms. So for the simplification purpose, we can take VA right hand side. We can get an VA is equals to minus V0 by AOL. VA is equals to minus V0 by AOL. So here, so we can get VA is equals to minus V0 by AOL. So we can have this equation. We can substitute in the place of an VA as a V0 by AOL. Simply we can substitute. I can write again here VA minus VA by R1 VA minus VA by R1 VA minus V0 by RF VA minus V0 by RF VA minus VA by R1 VA minus V0 by RF. Then we can get in the place of an VA is taken here, and VA means we can have already VA term minus V0 by AOL. So we can write V0 by AOL, and taken this R1 to this side, it becomes R1 by RF of in the place of an VA we can write minus VO by AOL minus V0. In the place of an VA minus V0 by AOA from the VA, and we have V0. So substitute here. For the simplification purpose, we can write like this. So here we can have VA term here, and R1 by RF taken minus V0 common. So minus V0 into R1 by RF 1 by AOL plus 1. So here, and taken this term to that side minus V0 by AOL. So here VA is equals to R1 by RF, and minus V0 taken common from these two terms minus V0 of 1 by AOL plus 1. We can get in the term plus 1, and this term is taken to right hand side minus V0 by AOL we can get. So it becomes VA is equals to taken these V0 to this side, then get V0 is equals to minus R1 by RF of 1 by AOL plus 1. We can get an minus is taken this side. So here minus 1 by AOL. Minus 1 by AOL. So we can gain ACL is equals to V0 by VA. Gain means output voltage by input voltage. So we can write like this: V0 by VA is equals to taken this term to numerator, taken this term to denominator, then minus becomes plus. So minus 1 by R1. So here minus na, here minus na. So minus 1 by R1 by RF of 1 by AOL plus 1 plus 1 by AOL. We can become the equation like this. From these we can write here. I can write here. From this formula, I can have why, because I can move this numerator and denominator. ACL gain is equals to output voltage by input voltage. So minus term is here. So minus 1 by R1 by RF of 1 by AOL plus 1 plus 1 by AOL. Then I can get here V0 by VA is equals to V naught by VA is equals to R1, sorry, RF minus RF. Taken this LCM RF AOL AOL. So minus RF AOL by remaining term is R1 plus RF. R1 plus RF. Take this LCM R1 remaining term plus 1 R1 plus RF and 1 plus AOL. Then 1 plus AOL. Simply we can get, I can write again here this term minus RF. Why? Because RF is taken to numerator RF and the AOL is taken to numerator minus AOL by, and the remaining terms are R1 plus RF. Remaining terms are R1 plus RF of 1 plus AOL. 1 plus this term is numerator, this side LCM, we can get an LCM, then 1 plus AOL. Dividing terms are going to numerator side, then we can get an answer like this, minus RF AOL by R1 plus RF of here R1, here LCM we can get R1 plus RF of 1 plus AOL. This is very easy to derive. This is a practical inverting amplifier. The output for the practical inverting amplifier is minus RF into AOL by R1 plus RF of 1 plus AOL. So now in the ideal inverting amplifier and not ideal non-inverting amplifier, in yesterday's class we already saw about the outputs which came to these inverting and the non-inverting ideal operational amplifiers. So here practical differential amplifier, the output for the practical, the gain for the practical inverting amplifier is this, minus RF AOL by R1 plus RF of 1 plus AOL. This is about the practical inverting amplifiers. In by tomorrow's class, I am going to explain about the input resistance and output resistance of inverting amplifiers. So here we have a practical inverting amplifier. The circuit is like this. We cannot apply virtual ground concept to the practical inverting amplifier. Why? Because it's a practical inverting amplifier now, so there is no concept of having the virtual ground concept. So VA is not is equals to VB, then VB is equals to 0. Why? Because we converting it into the ground. So connecting into the ground, so VB is taken as 0. Apply KCL at node A, then entering current is equals to leaving current. I is equals to I1 plus IB we can get. So IB1 is 0. Why? Because R1 is having high input impedance. So we can get in the place of an IB1 as 0. We can already substitute these. So I is equals to I1. So apply voltage divider rule at this circuit. I is equals to VA minus VA by R1. And the I1 is equals to VA minus V0 by RF. We can get from first equation we have I is equals to I1. So VA minus V0 by RF is equals to VA minus VA by R. So we have from the op-amp V0 is equals to AOL VD. In the place of an VD, the voltage difference between these two inverting or non-inverting terminal is taken as minus A. Why? Because VD, the difference between the non-inverting and inverting terminal is VD is equals to VB minus VA. So VB is 0 now. So substitute VB in the place of an VB 0 minus VA. VA is taken like this VA. So VD is equals to minus VA. So in the place of an VD, I can substitute my V minus VA. So I can get an VA is equals to minus V0 by AOL. Why? Because VA, for the simplification purpose, I can take the VA value like this. Why? Because I want only in the equation VA and the V0 terms. I don't need the VA term, so I can convert into V0 term. So I can apply VA in the place of an VA, V0 by AOL. Then for the simplification, I can apply V naught by AOL. Then I can get in the place of an VA, V naught by AOL, V naught by AOL. Then VA is equals to taken V naught as common, and the VA naught is taken to right side. Then V naught is taken to this side, left hand side. Then I can get this and numerator by denominator. Voltage output by voltage input is called as gain. So voltage VO by IVA is equals to minus 1 by R1 RF. So this term I can get. Then I can get here the output of the practical inverting amplifier. So this is about the practical inverting amplifiers. Tomorrow's class I am going to explain the another concept, which is input resistance and output resistance of amplifiers. So thank you.